Hi, I'm Patty, works with Amplify Science. I'm going to lead you through this unit orientation video for the third grade unit, Weather and Climate. In Weather and Climate, students take on the role of meteorologists as they gather evidence and analyze weather patterns so they can advise the Wildlife Protection Organization on selecting one of 3 islands for an orangutan reserve. Students learn that orangutans only live on the islands of Borneo and Sumatra in the wild. They have a combination of very hot and extremely rainy weather. The rainforests are being destroyed in that area to plant oil palm trees, and orangutans cannot live where those trees are planted. The Wildlife Protection Organization wants to build an orangutan reserve somewhere with very hot and rainy weather. They want our help to choose an island with the best conditions for a reserve. As students work through the 4 chapters, they gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they construct understanding about weather and climate and how data can be analyzed for patterns that will help them predict future conditions. This unit is an argumentation unit. In their role of meteorologists working for the fictional Wildlife Protection Organization, students investigate weather patterns as they solve the problem of where to establish an orangutan reserve. Deforestation of the orangutan's habitat as oil palm trees are planted is requiring the Wildlife Protection Organization to think about finding another very hot and rainy island for the reserve. Students are charged with analyzing the weather on 3 fictional islands in order to determine which has weather most like the locations where orangutans live, and recommend one island for the reserve. As they progress through the unit, students become increasingly adept in making sense of the data that's necessary to accurately describe the weather of a given location over time. They figure out how meteorologists collect, analyze, and represent weather data for one day, then for 1 month, and finally for an entire year. Students use digital modeling tools and support from the unit's books to figure out that weather follows patterns over time and across space. Using these patterns to make predictions about the future weather on the 3 fictional islands serves as the predicted phenomena for this unit. By the end of the unit, students are able to use their best evidence to support written scientific arguments for the location of the reserve. The focal cross-cutting concept emphasized in the Weather and Climate unit is patterns. In their role as meteorologists, students delve deeply into interpreting weather data over time and physical space. As students begin to understand that they can organize weather data in ways that allow them to find patterns, they figure out that they can use the patterns they discover to make predictions about when and where weather events, such as natural hazards and seasonal temperature change, will occur. Students return to the idea of patterns again and again throughout the unit in a variety of modalities. Every Amplify Science elementary unit also includes a focal sense-making strategy, which students leverage as they read and also during investigations. This unit's sense-making strategy is visualization. The main writing genre is scientific argumentation. Well, that's the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight 1 or 2 key evidence sources students use. But remember, in every chapter and every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students collect evidence to answer the question, which island's weather would be best for orangutans? They will investigate and learn about weather measurements, finding that weather has to be measured the same way to allow for comparisons. Key evidence sources in this chapter include students exploring ways to measure rainfall and comparing data from different measurement methods. They then use standardized methods to collect and record local weather data. At the end of Chapter 1, students return to the anchor phenomenon. They evaluate and sort evidence from the islands, and they write an initial argument as a class to answer the Chapter 1 question. They explain that the reserve should be built on Blue Island because it had the hottest temperature and the most rain on the day that data was measured. In Chapter 2, students work to find out which island's weather will continue to be best for orangutans. They discover that the pattern to the weather over a month allows for comparisons and predictions. In this chapter, students analyze data from a month's worth of weather from each of the 3 islands. They use a digital science practice tool to organize temperature data, analyze for patterns, and make predictions. At the end of Chapter 2, students evaluate and sort evidence from the islands and participate in evidence circles to discuss which island's weather will continue to be best for orangutans. As they write arguments to answer the Chapter 2 question, they're able to explain the reserve should be built on Creek Island because it had the highest temperature range and the highest amount of total rainfall over the month of available data. In Chapter 3, your class will try to answer the question, over many years, which island's weather will be best for orangutans? Students investigate and find out that the annual pattern of repeating seasons allows climates to be compared and future weather to be predicted. Key experiences that help students understand these ideas involve having students read what's going on with the weather and then discussing bar graphs from the book to help connect the idea of weather and climate. At the end of Chapter 3, students are able to explain that when looking at a year's worth of data, the reserve should be built on Ark Island because 1 year of data reveals that Ark Island has a consistent seasonal pattern. It is warm and rainy throughout the year, while Blue Island has a dry season and Creek Island has a cold season. In the final chapter of the unit, students will engage in looking at how they can protect buildings from damage by weather-related natural hazards as they work to protect the Wildlife Protection Organization offices from weather-related hazards. In this chapter, students analyze data about natural hazards and use maps to predict possible local natural hazards. They plan, make, and test model structures that can withstand hurricane conditions, and they write arguments about what changes the Wildlife Protection Organization should make to protect its office buildings from future natural hazards. By the end of Chapter 4, students can explain that weather-related natural hazards include blizzards, hurricanes, and lightning strikes. It's possible to implement a variety of protective measures for buildings that can minimize damage from these severe weather events. The Wildlife Protection Organization's home office building in Florida has already been damaged by a hurricane. Since this area also has a history of lightning strikes, students recommend solutions that could prevent future damage. I hope you're feeling excited to start teaching this unit. In addition to the resources on the Amplify platform, check out the at-home videos and the at-home unit to help you teach the unit this spring. The Spanish at-home unit will be out April 2nd. You can use any combination of these resources to engage your students in figuring out about weather and climate. Please let me know how I can help you plan for instruction. I'm Patty Works, and my email address is pworks@amplify.com. Thanks a lot.